In the section 5, Dendrogeomorphology, we have the following speaker and topic. Dambaru Balapkarel, temperature, topography, elevation, relationship in mountains, implication for climate analysis and modeling.
My findings could have implications for the climate reconstructions, especially from the thermal profile variability in the mountainous regions that reconstructed, as well as in downscaling, as well as calibration. That I have already mentioned that there is very challenges to work in the high mountainous regions. Because most of the observation stations are located to the middle area or the lower elevation regions where the dense populations live over there. So therefore, it is very difficult to get the high mountain regions informations, especially in the data informations, especially the changing patterns, especially in the variability to understand the climatic characteristics in the high mountainous region. And almost in the meteorological station observation stations are located into the below 3,000 meter, almost below 3,000. The near surface temperature lapses is highly crucial. That is vary with location and time, and vary with the in synoptic conditions, seasons, and that's why we need to kind of quantify in the specific locations to capture or to properly use for the hydroclimatic modeling. Himalayas and the northern part, mostly the dry and colder, basically in high level trajectories, just like that high level westerly system that originated from the Eurasian continent influenced the climate of the. And since I have initiated this study in the South Asian continent and in 2013, now there is more than 200 research publications in this regions and in this field, especially in the temperatures elevation relationship, especially in the temperature lapses quantifications of, in the study area. Mostly because this is also significant, not only to know about the modeling perspective, not only to know about the climate influences from the northern and southern slopes of the Himalaya. The first one, the important factors of that influence the temperature's elevation relationship or the temperature lapse cycle is the moisture and convection. And during the summer season, and mostly in the Indian summer monsoon, that dramatically modulates the slope or vertical profiles of the temperatures and the seasonal profiles of the temperatures that and keep apart from to the other variations with the winter. It means precise values for the modeling aspects, and mostly for the hydrological modeling the aspects, and mostly in the glacier mass balance modeling aspects, and temperature field interpolation and the snow dynamics study. And there, in conclusions, there is a scientific and practical implications of these values, derivation of these values. There is a scientific contributions, and also in the climatic modeling, as I've already mentioned frequently in my earlier slides, and practical implications in the glaciology, hydrology, ecosystem, and climate projections. And in various aspects, in various research. Okay, thank you very much.
Thank you very much, Dr. Carrett, for sharing such valuable insight on temperature elevation relationship and their relevance for understanding climate processes in mountains environments. Only share your screen. Yes. It's possible to see your screen. Put your full screen. Yes. Now it's possible to see.
Great. Okay, then I start. So my name is thanks a lot for the introduction, and also for organizing this Dendro meeting now, second year in a row. It's almost like a tradition now. My name is Johannes Edvardsson, and I'm working with a lot of different types of tree-ring research. So everything from small shrubs from Greenland to all the subfossil trees from peatlands to urban trees, but something that I've been working with in parallel with all these kind of research projects has always been what we called Dendroarchaeology. So, and this is very broad term, so it's not purely archaeological material, it's also a lot of cultural heritage material, so like standing constructions, buildings, art, music instruments, sculptures, etc. To these questions, even if the questions are quite simple and logic, and like how many tree rings do I need? It's like similar to ask how long is a rope. I've succeeded to date something with 35 rings, but sometimes I've failed with 200 rings. So there's no easy answers. But to try to explain this for the end users, me and two colleagues from Lund started to collect the metadata from our reports, and we used metadata that is accessible on this strategic environmental archaeological database, and so we good report. So this was an attempt then to answer some of the questions from the end users. However, if the end user send us the samples and then we are making our analysis, then we are supposed to deliver a report to the end user, and then we maybe write in the report that, okay, the first sample that was a tree, it was felled during the winter 1544 to 45. The second sample was terminus post-quem dating. The third sample was undated, etc. And there might be new questions to be the third option. Then we have the heartwood, and then we have sapwood, but we don't have a complete sapwood. Then we rely on sapwood statistics to estimate how many missing rings there might be, and we might write the dating plus minus 5 to 10 years, something in the report, depending on how good statistics we have. But now the case was the fourth core, so the option number D, we only have the heartwood. So then we know that we need to add the minimum number of missing sapwood rings, and that would be the earliest possible felling year of the tree. Surface preparation, so like clean this surface a little bit with a razor blade. However, this might be controversial because these panels might be expensive. So this is a panel painting by Rubens, and it was sold at Sotheby's in London for more than $76 million. So of course, people that own or protect this kind of art, they don't want you to do invasive studies maybe on this. However, there are a lot of non-invasive methods that we can use to study tree rings. So this is one test I did to do test a micro CT scanner to see how we could, if we can get good images of the tree rings from a core. So I was just playing around a little bit, but it's really amazing what you can do. However, the problem is that there are quite few micro CT scanners available, and it's a huge project to get expensive painting from a museum to a different lab with transportation costs and security and everything will be very expensive. So even if we can get amazing images like this without doing any invasive surface preparations, we can't use this method very often. I have tested also CT scanners at hospitals. However, the resolution are usually not good enough on those scanners. Like the smallest bone in the body is the bones in the ears, and they are roughly 2-3 millimeters, but so they don't need the same resolution on their scanners as we do. So interpretation that these two paintings were made at the same time, because then probably Rubens went to a panel maker and bought the two panels at the same time, and the panel maker made them out of wood from the same delivery, so planks from the same tree. So, and then two different planks from the same tree ended up in two different paintings. So to summarize a little bit, I think that two-way communication between dendrochronologists and end users improve cultural heritage studies a lot, and not just cultural with archaeological or historical method. I also think like in paleoecology or in forest history reconstructions, that this kind of communication is very important, and it should be integrated at several different stages. Like, and we should discuss the sampling design together, like, because we might, as dendrochronologists, might not always know exactly which part of an old building that is original or changed, or that's been built a decade later than the oldest part of the building. That kind of knowledge the building.
Thank you very much, Dr. Edvardson, for your excellent keynote. Your presentation showed how innovative dendrochronological techniques is possible to protect and understand how is the very important our cultural heritage. So we have time for questions from our audience about the Dr. E.A. Robertson. He is a reader at Sunset University and a leading expert in stable isotope analysis of terrain to understand natural climate variability. He is former president of the Terrain Society and currently a visiting professor at Nicolaus Copernicus University, with additional research on biocar application for population and microplastic remediation. Very interesting topic today, because we are facing a lot of type of microplastic pollution, and it's very important, all this type of remediation. So you are welcome, Dr. Ian Robertson. Maybe, okay, yeah, yes. It's possible to see your presentation, and you are welcome, Dr. Ian Robertson.
Hopefully I've just shared the screen. Can you see it?
Yes, it's possible to see and hear you.
Perfect.
You're welcome.
Okay, thank you, Kelly, for inviting me to give a talk, and to thank the organising committee as well. My talk is on the bristlecone pine record and a search for abrupt climatic events. And of course, as a dendrochronologist, we have the advantage of when we get a chronology, it's absolutely dated. We know the date to the nearest year. And that's one advantage over virtually all other proxy records. And it's something I think we need to keep reminding people, because people do forget. It's important that, of course, when you're doing international research, there's nearly always a big team involved. In this case, I am giving the presentation, but it could have been several colleagues, no doubt about it. So from paleoclimatology, the question is, are there any other records that we can look at going back in time where a similar thing may have happened in the past? And moreover, can we learn from it? And a similar event did happen 8,200 years ago. It's called the 8.2 kiloyear event. And there's a good illustration of it here. So essentially, Europe had been, and North America had been covered in ice for a great period of time. Gradually, as it got warmer, the ice sheets started to retreat. And here we have a summary paper by Sarah Parker and Sandy Harrison a couple of years ago now, where they looked at 275 speleothem records, which have now been put into a database. So you could say there's a globally extensive, coherent and synchronous climate response to something that happened 8,200 years ago. We're particularly interested in it because we're lucky now that AMOC is continuously monitored. But there's renewed interest, of course, because it could happen in the future as a result of global warming. So where can we look for additional records? We've got the ice core data from Greenland, which is brilliant. Is there any more information? Well, of course, there's the ancient bristlecone pine record in the United States. We know it's been used extensively for radiocarbon calibration. It's been used for paleoclimate work, but bizarrely, the actual modern calibration period is quite problematic in that region because we don't have long instrumental MET records. They've been established, but they're relatively short. So, and looked at oxygen isotopes from relatively high resolution records, including lakes, bogs, marine and ice cores. As they experience extreme water stress, as you might expect, they have very narrow or absent rings. They're very common. With this in mind, of course, dendrochronology is going to be challenging. Dendrochronology will be a problem because of the absent rings. If you look at the photographs on the top of the screen, you've got a sample. The first thing you must do is cross-date it. So you've got an isolate alpha cellulose. There are many methods out there. For a while, something called the Brendel method became quite popular. We developed a method, as in Neil Loader and myself, where we essentially learned from wood chemistry. So all we did was bleach the lignin part of the wood away. And this is the equation. The delta 13C value of the plant or the tree equals the atmospheric value minus two constants, A and B, and then Ci over Ca. But clearly, at a period which I can say began at 8239 BP, the carbon isotope values started to become much more positive in 3 of the time series. The fourth one at the bottom of the screen doesn't quite cover that exact period. And he looked at carbon isotope values throughout the entire 1,000-year bristlecone pine record, and then he used that to reconstruct precipitation. But the key bit here is I'm just showing the carbon isotope anomalies over 1,000 years. And none of the changes are as large as the ones that was recorded at 8239 years before present. 4 samples were absolutely dated against the existing bristlecone pine master chronology using skeleton plotting. It worked incredibly well. And what we found is there was a pronounced carbon isotope anomaly covering a 30-year period, indicating the onset of drier conditions in the bristlecone pines in the White Mountains, beginning at 8239 years before present. Okay, thank you very much for your time. And now I'm going to answer a few questions if there is time available.
Thank you very much, Dr. Robertson, for this compelling keynote and very interesting research that you are working, where especially carbon isotope evidence from this type of species provide a powerful windows into a broad climate change. We can see your presentation. Now only put in full screen.
Okay.
Yes, it's ready.
Okay. Hello, everyone. My name is Luis Ubaldo Castruita Esparza, and I am affiliated with the Facultad de Ciencias Agrícolas y Forestales, Universidad Autónoma de Chihuahua. And I am very grateful to Ecuadendro 26 and Kelly Peña for the invitation. It's a pleasure for me to be here with you and share some of the work we have been doing. See what is happening with the different ecosystem, in this case with Picea chihuahuana. Picea chihuahuana is a long-lived climate sensitivity species driven specific habitats along the Sierra Madre Occidental in Mexico. Currently, the species is considered in danger of extinction and is included under protection of Mexican norm 059. This is by Semarnat. The objective was to investigate dual isotopes and physiological responses of Chihuahuana to climate extremes and increasing atmospheric carbon dioxide. Measurements of delta 13 carbon and delta 18 oxygen were performed using bulk wood of individual trees. Aliquots of millet wood samples were weighted in Sartorius microbalance. For this part of the slide, you can see more information about the different concepts in the formula. Results and discussions. In the figure B, you can observe change in 13 carbon over the time were significant, minor to this 0.05. In this sense, the seed reflects the dilution effect of the atmosphere. Additionally, in the figure C, change in 18 oxygen over the time were significant at the seed in the Sierra Madre Occidental. And the source of water of the Sierra Madre Occidental trees may be using a different water reservoirs over the time, as suggested by Saris. Intrinsic water use efficiency have significantly increased over the time, but tree growth shows to be declining. And in figure E, 13 carbon discrimination were significant too. In this figure, dual isotope analysis in relation to the conceptual model of Scherer, you can see the behavior of the different periods that we use in the isotopic analysis, dry and wet periods. And three physiological response to change of atmospheric carbon dioxide includes a depletion, 13 carbon, and rising intrinsic water use efficiency over the time. And these results indicate that the intensity of the climatic effects on the tree physiology are being severe over the time, pushing the health of forests to a critical level. And studied forest ecosystem has increased intrinsic water use efficiency in the last century, adjusting proportionally radio A and GS with no evidences of improved tree growth due to the fertilization effect, increase of atmospheric carbon dioxide.
Thank you very much, Dr. Castrita Esparza, for this interesting and insightful presentation demonstrating how these dual isotope studies reveal long-term physiological response in this type of species to climate extreme and rising atmospheric carbon dioxide we are faced today in our world. Very interesting topic.
Okay. Hello, everyone. Welcome to my presentation about our recent study on variation in population structure and site conditions do not alter hydraulic strategies of Mangifera sylvatica, but underlying drivers differ across South Asian moist tropical forest. South Asian moist tropical forests, particularly those in Bangladesh, are increasingly threatened by climate stressors, such as in monsoon, there is intense monsoon and the temperatures is rising day by day. For this study, our study sites, there are two study sites, Ramakalenga Wildlife Sanctuary, which is RKWS, and Kappe National Park KNP, where a total of 180 increment cores and 60 branch samples were collected from 60 trees in two study sites. After scanning, vessels are measured through Winsel software. And finally, xylem hydraulic traits are calculated. Results reveal that there are significant variation in population structure and growing condition between these two sites. For population structure, Mangifera sylvatica in RKWS had significantly higher DBH tree height. DBH means the diameter at breast height, higher tree height and crown surface area, but lower bark thickness and wood density. For growing condition, Mangifera sylvatica in RKWS was grown in soil with higher soil moisture content, soil organic carbon, soil porosity, and clay content, but lower pH and silt content than KNP. Driving factors, if we say about driving factors of hydraulic efficiency, in KNP, hydraulic conductivity Ks had significant positive relationship with tree height and crown surface area, but negative relationship with soil sand percentage. In RKWS, hydraulic conductivity Ks had significant positive relationship with tree height and crown surface area and sapwood length, which is denoted to PLC. In KNP, PLC of Mangifera sylvatica population showed significant positive relationship with crown surface area, but in RKWS, significant positive relationship with tree height and sapwood length. The key finding of our study is Mangifera sylvatica exhibits a conserved hydraulic strategy across heterogeneous environment. In each forest, the population of Mangifera sylvatica relies on different structural and environmental mechanisms to maintain hydraulic functions. This hydraulic conservatism indicates its adaptive capacity under current condition, but potential vulnerability under rising vapor pressure deficit. The limited plasticity in core hydraulic architecture implies that the species' adaptive capacity may rely on structural adjustment than on modification to xylem anatomy. I would like to acknowledge Forest Department of Bangladesh and Shufal project for funding this project, this study, and our wood lab team for their help. Thank you for your kind attention. If you have any question, you are welcome.
Thank you very much, Mohamed Marcelin, for your nice presentation.
What I wanted to talk to you today about was some applications in the policy relevance of dendrochronology. So first of all, we all know there are thousands of tree ring chronologies and many types of reconstructions and records that have been developed from those chronologies, for example, temperature, stream flow, earthquake. Some reconstructions have a very strong signal, and we also know that technological advances are constantly improving on the extractable signal. So just by way of example, one from Hans Linderholm. This is a temperature reconstruction. Excuse me. And what we can see here is that conditions around 1600 were relatively cold. And again, if you look at the smooth line, that since 1900 they've been generally above average. So we know that this kind of reconstruction provides some really useful context for understanding our conditions today. But what we really want to do is ensure that this kind of work is used in policy decision making, because it has some very real implications and meaning for management. What I wanted to do was just give a very brief overview of some areas where dendrochronology can provide policy relevant insights. Then I want to highlight some of the barriers to better embedding paleo work or dendrochronology specifically in policy and decision making. And finally, just I want to think about some possible facilitators of better embedding dendrochronology and paleo generally into decision making and management. So the first example I want to show you is fire histories. So this is one from Andreas Holtz, who looked at your forests for fire in the current day. Here are a couple more studies from Asia, one from Bhutan, one from Vietnam. So if you look at the Bhutan example first, this is data produced by Karma Tenzin. And he looked at a number of sites that were burned within a part of central Bhutan. And what he found was that there was an uptick in sites that were burned from about 1970. And that was very interesting because in 1969, the Bhutanese government introduced the Forest Act. So what this Forest Act did was basically take humans out of the forest. So humans could no longer graze their animals in the forest. They couldn't collect firewood in those forests. So you're taking people out. And what Karma thinks happened here was that by taking people out, you've got the fuel sources are building up because they're not being removed each year. And so when the fires burned, they burnt across a larger number of sites simply because there was more fuel build-up. The site in Vietnam, you've got a similar kind of thing happening. So this data was collected by Tiet van Nooyen, and the uptick here is slightly earlier, 1960s. And again, there was a government policy introduced, but this time what the Vietnamese government wanted to do was move people out of the cities into more rural and regional areas. So they moved people into the forested areas. And in this case, what happened was that there were more ignitions. So humans, as an ignition source, were lighting fires and they were getting away. So you had more sites burnt from that period onwards in Vietnam. So these types of studies can show you what the impact of different changes in legislation or land management practices have been. And that's useful information for how you might manage going forward. Here's an example from Forest Ecology. This is by Dario Martin Benito. And he conducted some thinning experiments. He had a control site and a couple of thinned sites. This one relates to inflow into a lake. This Lake Burberry is used to produce hydroelectricity for Tasmania, and some of it's exported to mainland Australia. So I created these or developed these reconstructions of inflow into the dams for two different seasons. You've got summer on the top, winter on the bottom. The summer one is definitely the stronger, statistically speaking, reconstruction. And you can see there that there's a bit of a dip around 1500 in particular that was relatively prolonged, so a fairly dry period. The winter reconstruction, considerably weaker, but still statistically useful. And you can see a downward trend generally in both of those from 1500, which is interesting. So that in itself gives you a bit of context for what's happening now, but we can go a little further. So my colleague Danielle is a water resources engineer, and so she took these reconstructions and she downscaled them to daily data. So daily data is at a time resolution that water managers can relate to. So a seasonal level data, they find these curves interesting or perhaps scary if you're looking at 50 tips. Obviously, this is going to create barriers to paleoscientists providing information in a form that business understands and business taking up the paleo data. Work practices also differ. So again, governments tend to be conservative. There's a bit of inertia. Again, legal issues, rigid structures and so on. Paleoscientists certainly not geared towards applied problem solving much of the time. That's changing a little bit. Often work in small teams. Then there may be issues associated with tenure or changes in the university system. So there's often a mismatch between the two groups in terms of temporal and spatial scales that they're interested in, different languages, different funding constraints and timeframes. So we all know that paleo information has a lot to offer to the policy world. So if you take archaeological information, historical, First Nations knowledge, as well as paleo-environmental knowledge, all of this can tell us something about climate change and or socio-ecological resilience, and it might feed into, we can see that it can feed into sustainable development goals, for example, but there are other policy areas and projects that it can inform, or other management things it can inform as well. So if we think about those characteristics and the constraints, we can identify opportunities. So the key ones, I won't go through this in detail, the key ones are going to be around interaction and communication. There's lots of things that could be done there. Placements, secondments, conferences, workshops. And when I say conferences, I'm not thinking science conferences per se, but conferences where people can get together across interdisciplinary, embedding paleoscientists with decision makers, embedding decision makers into a science team, conferences and workshops, as I mentioned. But with this iterative process, it's not just one iteration, it goes on multiple times, and you can think about what you learnt during co-design. How can you apply that next time? Eventually, you will get your scientific publication and a co-produced report, and maybe that'll take a little longer, but the benefit will be that the information is more readily taken up by the managers because you've put the time into trying to understand what they need and providing them with that. And they will better understand the paleoscientist. So you might do your publication, co-produce your report, and then you can do your social media press release, etc. It's a longer process because it is iterative, but the benefits can be a lot higher. So in summary, we want to ask why we're doing the work in the first place. We know science provides the critical insights into many problems, and we know that a lot of the information is not taken up, but we shouldn't get aggro about that. It's a longer process because it is iterative, but the benefits can be a lot higher. So in summary, we want to ask why we're doing the work in the first place. We know science provides the critical insights into many problems, and we know that a lot of the information is not taken up, but we shouldn't get aggro about that because often it's because we don't understand their needs and we haven't taken the time to find out how they want the data and how would it be useful. I'd say that flashy science that wins many brownie points is not really going to be relevant to them if it's not grounded in policy and management and if the data can't be used by policymakers and decision makers. So you need that co-design right from the start. And there's a need to build sustaining and useful partnerships that go beyond just the one project. Interdisciplinarity is really important for good co-design and useful information. And we should consider the importance of what we'll call boundary work or translation that happens between the science and the policy makers, the managers and the decision makers. I think that's really key and again feeds into thought that goes into co-design. All right, I'll leave it there. And if you've got any questions, please.
Okay, hello everyone. Here is Kelly, the Dendro lady from Ecuador. And I am very happy to share with you the recent project that we're working here in Ecuador in the tropic. My topic in this scientific meeting is related on recent advances in dendrochronology focused on climate and environmental governance. My affiliation, FAU University in Germany and Ecuadendro Tropical Research. So we will continued. Okay, like an introduction, starting from the more inside of the tree, related on what anatomy features and terrain. This is very important variables because they are the mechanistic foundation for understanding all interaction that there are when we are related with different environmental variables or climatic variables. Wolf anatomy and theory, they are formally recognized by the IPCC like a critical, paleoclimatic indicators, empirical precision necessary, bridge regional data gaps, and because it's possible to transform all these biological growth patterns in scientific evidence for international climate frameworks, science-driven governance. The objective that we need to know more a little more for this research that we are working here in Ecuador is the following. Analyze the wolf's anatomical trace to bring a stable isotope to decode climate signals in tropical species. Bridge the terrain science with environmental law through dendroregulation initiative. Influence climate frameworks and governance using evidence-based standards, and foster global scientific collaboration in capacity buildings via Ecuadendro Conference and Dendrocopa Fellowship. The research that we are working here in Ecuador, we have two sites in northern Ecuador and southern Ecuador. In northern Ecuador, we are working in the tropical moist forest in northwest Ecuador, in the Esmeraldas province. And the other side is in southern Ecuador, in Loja province. About our recent advance in dendrochronology in our type of forest is related on anatomical characterization of Ecuadorian forest species, tropical moist forest in northwest Ecuador. Made outright measurements about all quantitative wolf anatomical features and made outright description using our wolf anatomical norm for make this characteristic. In section code, we can observe that the major of the cells, its characteristic is formed by procumbent and square cells. Yeah, this is related on the wolf anatomical feature focused on qualitative description. Related on the quantitative, wolf anatomical quantitative variables or characteristic, we apply an innovative statistical technique or method called statis dual. The next project that we are working is related about decoding dry forest resilience, climate impacts on Bachelia macracantha wolf traits. To address this research, our primary objectives are to characterize the interannual variability of ring width and vessel anatomical traits, in this case, average vessel lumen area, total vessel lumen area, and vessel density, using these species, Bachelia macracantha, to develop a standard ring chronology and vessel trace chronology for after evaluate their interannual variability and synchrony. I am explaining in this research. So here we can accomplish our ring chronology. We are using the DPLR package. We apply explain cubicote training for accomplish our tree ring chronology in all our was anatomical chronology tool. Here we can observe that the relationship that we are working with this species was with climate data from our regional station from Ecuador and data from the climate explorer. Understand how it's work with the climate variables, tree ring isotope chronology. So in this way appears dendroregulation. Dendroregulation is related with the tree ring evidence to improve climate governance in the Código Orgánico del Ambiente COA environmental policy in southern Ecuador. To promote the use of forest species with dendroclimatic potential that these species offer us. This is the topography of our dry forest in this Laipuna natural reserve. We related with data from our national station called INAMI and the data from the Climate Explorer using the CRU climate data. After number 2, related on the environmental powers of the decentralized autonomous governments in these articles number 27 of the powers of the metropolitan and municipal autonomous government in environmental matters, and with the purpose of including one more faculty, because is where when a global initiative appears. So we met with different dendrochronology college and working in this global initiative. And with this all interaction that this chronology have related to the climate or environmental variables, and understanding this dendroclimatic potential, we propose this enhancing. This way, we accomplish 29 regulatory amendments implemented across 24 countries. The tree ring evidence supported by 29 regulatory amendments across 24 countries addressing drought, forest conservation, climate adaptation, and water management. These results highlight the value of tree ring for guiding science-based climate and environmental governance at the global scale. Achieve interesting scientific meetings like this. We have the last year a priori scientific meeting that was our first Dendro meeting in Ecuador. Very interesting project that we are working. Board a Dendrocopa project related on fellowship in the last year, where it was possible to select one students for being after training by Ecuadendro Tropical Research and made this scientific collaboration. This is our project that we are working in Ecuador.
I'm here today to present our research project, Dendrocopa Initiative, Advancing Dendroecology and Forest Structure Analysis from Ecuadendro Tropical Research in collaboration with the North African Research Fellowship. We start with the introduction. Tree rings are powerful natural archives linking forest dynamic and climate variability. Dendroecology reveals how trees respond to environmental stress over time, integrating those insight into forest policy strengthens climate adaptive and sustainable management. Our general objective is to evaluate forest dynamics through dendroecological methods using the statistical methods. Our specific objectives are create an inventory of individuals with secondary growth and collect wood samples using an increment borer, to develop a tree ring chronology of the species, Pinus or the stone pine. Also analyze the data using the innovative multivariate methods, keyways, that is the wall, to access the influence of climatic factors on the radial growth of Pinus, and finally to propose an amendment to the forest regulations in Tunisia. The methodology: quantitative variables for 20 trees stratified by chrome class, emergent, dominant, codominant, and subdominant. Our study area is located in northwestern Tunisia of Jandouba, Adisa forest. So perimeter, height, chronology, length, DPH, basal area, steam volume, chrome dimensions, area, base, height, and volume, and geographic coordinated latitude and longitude, time, points, or variables. Status stage: enter structure per tables, air vectors coefficients to identify the similarity. Compromise builds consequence structures to a global pattern. Intrastructure projects table to trajectories and dynamics. Tree ring width were measurement using a LinTab system with Sapwin software, and cross-dating quality was validated using Kofecha software and DPLR in R. Tree ring chronology was correlated with KNME TS climate data to access growth sensitivity with tree clean package in R. Dendro regulation policy application of the Tunisian Forest Code. Present the common structure shared by all datasets. The compromise analysis revealed a decoupling between current forest structure and long-term growth history, while structural variables like DBH, height, and chrome volume are highly integrated, defining the stand's immediate productivity. The chronology length operates as an independent factor. This indicates that a tree's current size is not a direct proxy for its age or historical resilience. Growth of Pinus piña. We correlate the climate to find a good growth limited by spring-summer temperatures. Growth favored by late year precipitation is a Mediterranean type of drought response. Now with the Dendro regulation policy application, the context: Tunisian forest 1988, 209, protection of flora and wildlife. Proposed amendment, the article 209.1, dendroclimatologically significant species and long-lived trees specimens shall be included in priority conservation list. Preservation is mandatory for scientific research and climate change mitigation. As justifies amendment 209.9, prioritizing long-lived specimens as essential reservoir for climate resilience. So, forest structure explain how trees grow today, but tree ring explain how forests survive the past. Protecting all trees means protecting climate memory and future resilience. A special thanks to Dendrocopa International Fellowship 2024 2025. This research was made possible through the inaugural training in dendroecology and forest structure provided by Professor Kelly Penna. Thank you very much. Her mentorship was fundamental for the experimental final analysis. The training was very nice and smooth. Thank you for your attention. This photo, my certificate. Thank you.
Basically, as has been introduced, I would share with you the experiences that we have had the past 5 years from 2021 to 2025. So basically, this is 5 years in the field where here in Africa, we are advancing the dendrochronology, specifically focusing on the tropical trees and also building capacity on the continent. So this is the work which has been done by with a number of collaborators. And if you see below, this is a key team that has been working on this field work to advance dendroscience in Africa. So basically, if you see this screen, we are looking at a picture of the global picture and also what is happening in Africa. So what we see in red, these are the labs and the research that have been conducted at global level. And this map is a 2013 map. So definitely there should be some. So what we are seeing here, we are seeing a big gap. What is happening around the world and what is happening in Africa, the gap is just so huge. And basically what we are seeing, which is very clear, is that we are seeing the dendroscience, dendro research being conducted so much in the north compared to the south. So the gap is very, very clear that we feel it needs to be filled. Now, the question that we might have is that why is it that we have very limited research that has been conducted on the continent of Africa? The answer is very simple. One big problem that we're having on the continent is the human capacity. We can do research anywhere in the world if we have the human capacity. It's not just money. Anyone can give you money, but if you don't have human capacity, then there's nothing you can do with the money, even if somebody has got money. So human capacity has been a very big problem on the continent of Africa, especially the human capacity. How do we build capacity on the continent of Africa? Hence, we established what we have called the African Dendrochronological Field School. So this school was established at the Copperbelt University. That's where we started from. And we have been running this field school for the passions. And basically the field school that we have been offering, we have been inspired by the NADEF, North American Dendrochronological Field Week model. That's the model that we have been using. So it's a model that has worked before. All what we are doing here is just to adapt to the current situation, to the African system. So with time, we hope we will be able to try to train enough capacity to ensure that we have enough resources, enough capacity on the continent of Africa. But all in all, we were inspired by applying the NADEF system. We have seen that it is working very, very well at 28.5%. And what we found is that, as I indicated, there are some trees that where you can see the rings very clearly, very, very, very clearly. But others, you cannot. If you look at this just in general, you'll find that some of them, like this one, you'll be able to see the rings very clearly. But others, you find that you really have to work so hard to see whether it's a ring or not. Some of them, you literally cannot see the rings. So as we can, if we can't identify the rings, we report it in that way. If we can, we report it in that way. Then 2024, we went to the southern part of Zambia, the drier part, and this one is receiving rainfall of less than 700 millimeters. And in 2024, we identified 17 tree species, very diverse, and usually we don't even cover a very big area because considering the time, but even within the small area, we are able to identify as many species as possible. So as usual, we found in some trees, they form very clear rings, but others, like you can see, if you see on your right there, it's very, very difficult to see the rings. But some of them, like the Brachysphagia speciformis on your left there, that's the second last there. On the Brachysphagia speciformis, the rings are quite easy to see. So these are the kind, if you look at, for example, Combretum there's almost like no ring. Almost everything looks the same, but you really have to pay so much attention to see if the rings are visible or not. But it's quite a number of work, a lot of work. But when you give it more time, you should be able to identify the rings in most of the species. But some of them really, it's very, very difficult to see the rings. Continuing with the dry Miombo woodlands, what we found is that the total precipitation, what we found is that the previous December and current March precipitation, they have a positive influence on the tree growth. And just like the drier part, the wetter Miombo, most species are diffuse porous. 2025, this is last year, we were again in Southern Province, where we are also now. And also there are a number of conference papers that have been presented in different forums. So this is something that is really helping us to advance the science. And at least we are now able to see the results slowly through the publications and the conference paper presentations. Then another component apart from the research is the capacity building. What are the output? So as we are conducting the training, we are doing the research, but we also want people to gain some skills on how to do this work and how to apply this science. So far, from 2021, we have trained about 77 people coming from 18 countries. And because the training has been conducted in Zambia alone, we have trained more Zambians than other countries. But our goal is to rotate to other countries within the continent. So we are now currently looking for funds to see how can we support this activity to make sure that it also goes to other countries. We want to train as many people as we can so that with time we can have labs on the continent of Africa that can be applying the tree ring science. Okay, so when finances have really played a part for many people not to come for the training. But we can see the indication from the applications that we are receiving every year. Then because of this training that we have been offering, we have managed to establish the Dendro Lab. So at the moment, if anyone wants to do basic research in dendro science, we have the basic equipment that we can use. We have the microscopes, we have the LinTab, and the software that has been donated by the developers, the seed dendro and the Cool Recorder. We don't need to worry. We have the license has been donated by the developers that we are using at Copperbelt University for training and also for research. So we have all what it takes, at least the basic facilities that we need for us to conduct research. Hence, we are inviting anybody who is interested to come and do research. they'll find the basic facilities for them to do research. If you want the facilities, you can come and use the facilities. Then you can do any other things. You can be doing other research wherever you are. But we have the lab, we have the equipment, we have the software. A student can be here, come and use the lab that we have established. For those with masters, they can do their PhD. And this one is also by research. You don't need to come. But if you want to come and use the lab, we have the facilities that any candidate will use for them to do their research. So this initiative, the programs now are under development. And immediately they are ready, we are still going through the approval stages. And immediately the final approval is done and accredited by our higher education authority, the announcement will be made so that those who are interested, they can come and register and pursue their degrees. So as I said, this program that will be running will be focusing on the application of dendro science. So what is the key take-home message? So what we have seen here, what we have learned from 2021 to 2025, the 5 years that we have run the ADF, basically what we have seen that the ADF is really a powerful tool, a very, very powerful platform that we can use to build capacity within a short period of time. Unlike maybe somebody who come for maybe 2 years, or somebody takes 3 years, or somebody takes 5 years, within a short period of time, people are able to understand the basic research and are able to do basic research. Very, very much thankful to all these partners who have made this program really possible. Everybody has contributed in different ways. For example, University of Cambridge, they donated all the microscopes that we are using. Then Dendro, Recorder, the license has been donated. We have Indiana State, all these others, NSF funds, there are funds that were dedicated to this program through our colleagues whom we are collaborating with from the US. Haglof has been there, Pages has been there, ATR, Association for Tree Research, every year they sponsor candidates to come for this training. Tree Society has been sponsoring candidates. So everybody who is here, World Forest ID, they even gave us part of the equipment, the scanners, all these sponsors, they have really, really made our work very easy and possible for us to train the candidates on the continent of Africa. So with that, I want to thank each one. I want to thank you for listening. And now I can welcome the questions. Thank you so much.
Thank you very much, dear Dr. Justine Ngoma, with your interesting talk, very important for Africa. I am sharing with you all this project because the same happened with our countries. For example, here in South America too, and always we are very motivated to advance in this type of research, especially dendrochronology is a very passionate topics. And there's that we know that dendrochronology are inside for climate decision and all this topic, very important for our planet.